Alright guys, welcome back. And this is probably the last video I'm gonna make for lesson 4.1. Let me go ahead and erase all this here. In this video we're gonna cover an example of what we discussed so far. So in this example here, given a function, we want to find first the critical values of the function, and then second to identify this local minimum or local maximum of the function. Okay. When we get to the applications, these critical values will be the level of production that yields a maximum profit or minimum cost or whatever that would be. So this first couple lessons, it's still going to be very abstract in terms of a lot of math examples and not much application just yet. So let's go ahead and do this problem, okay? So to find critical numbers, recall that critical numbers defined as when the derivative is equal to 0. All right. So to do that, part A, to find critical numbers of values, we set f prime of x equal to 0. That means we have to find the derivative of the function. So f prime of x equals 3x squared minus 18x plus 24 using the power rule, and we want to set this equal to 0. Recall that to do this we use factoring techniques. Go ahead and take out the GCF. That gave us x squared minus 6x plus 8 in the middle. And then we can go ahead and divide the 3 both sides to get rid of the constant. Okay. And then that would give us x squared minus 6x plus 8 equals 0. We can factor this into x minus 4 and x minus 2. Therefore, x is equal to 4 and 2. So these are critical values or number that we just found. Okay. Now part B is we asking to find the local maxima, local minima. So if you go back to the first example or the graph example that we did earlier, the critical numbers give the derivative equals 0. So at those locations, the function either obtain maximum or minimum here. And we kind of generalize that down here, right? We have a maximum at critical value. We have a minimum at a critical value. And what does that mean? It means that, we can look at the change in the tangent slope sign, go from negative to positive or positive to negative, or where the function is increasing or decreasing, multiple way of doing it. So to answer this question, we are going to draw a sign chart. This sign chart, we're going to label this is the first derivative test or the first derivative sign chart. Okay, I'm going to go down here. Okay, to find local extremas, we use the first derivative sign chart. Okay. All right. So to do that, we draw a horizontal line. Okay. So this represents the domain or the real number. We're going to label the critical value. So draw this chart. So we're going to label the critical numbers at 4 and 2. So let's say here is 2. Here is 4. And I'm going to draw it like that. We're going to separate the x-axis in this case. So this is our x-axis. Let's separate that into 3 regions. We can say that this here is from 4 to infinity. In this case, from 2 to 4. And then this is from negative infinity to 2. Okay. So to see whether there's a minimum or maximum, we're looking for increasing, decreasing derivatives or increasing, decreasing function values. Positive sign changes of the derivative. So if a chart is saying that first derivative sign chart, this means we're gonna go ahead and look at the signs of the derivative at these locations around these critical values. So these are critical values. So we know that at this location with these numbers here, the function either obtain the maximum or minimum. We don't know exactly which one is which, but by observing the signs of the derivative, it will tell us whether it's a local max or local min at these positions. So we're gonna pick a test point. So I'm gonna go ahead and pick a point to the left of 2. So let's say we're gonna pick -3, for example. Okay, so this is another thing too as well, is if we test one of this value of x and look at the derivative of that, and whatever the result is gonna be, it's gonna be true for the entire region in this section here. Okay, so how do we test for the sign? So we said if x is -3 in this region here, let's go ahead and look at the value of the derivative at -3. Okay, what is that value? Here is the derivative. Okay, what we're really interested in is this in the factor form. Okay, so I'm going to go ahead and plug in -3 minus 4 times -3. Might have to erase this here. So let's go try that again. So f prime of -3. We know that x minus 4, x minus 2. So x is -3 minus 4 times x minus 2. So -3 minus 2. So we don't really need to calculate what this actual value will be. All we need to do is look at the signs of this number. So we have a minus, subtract 4, that's a -7. And we're going to times that by a -3, subtract 2, that's a -5. So that's the sign's going to be negative as well. So if we have a negative number times a negative number, that's going to be a positive number. So in this case, the sign of the derivative is positive. That means greater than 0. Let's move on to the middle part. I'm going to go ahead and pick a test value, or an x value that's tested. Let's say we pick 3. And then observe the derivative sign at -3. Okay. And then let's see here. Oh, I think I messed up. It should be 3. Okay. F prime at 3. So we have 3 minus 4 times 3 minus 2. Okay, let's look at the sign. So that's going to be a negative, and this is going to be a positive. So that gives us a negative for the derivative at 3. So that means the slope of tangent line is going to be negative, meaning it's going to be less than 0. And now let's move over here and pick an x value in this region from 4 to infinity. Let's pick 5, for example. And let's observe the sign at 5. Okay, so that's 5 minus 4 times 5 minus 2. I'm going to go ahead and just write down the derivative up here so we can see that a little bit. So we're going to do x minus 4, x minus 2. So remember, we only interested in the sign of the number when we plug in these inputs. So we don't care what the actual number is, because all we want to know is the derivative positive or negative. That will associate, is the function increasing, decreasing. That will tell us whether we have a minimum or maximum at that point there. Okay, so let's see here. Minus 5, subtract 4, that's going to be a positive result, times 5 minus 2 is going to be a positive result as well. Oh, I don't want to write 3 here. We don't need that. Just say positive. So that's going to be a positive answer. That means the slope's going to be positive. That's going to be greater than 0. Okay. So what does this tell us? Okay. So I'm going to go ahead and summarize this. Okay. So now the slope is positive. The tangent slope is positive, or the first derivative is positive, meaning the function is increasing. F is increasing. It's going to go from increasing to a negative derivative, meaning it's going to be decreasing. Okay, for the function y, and then back to increasing. Okay. So that means we have a situation like this here. We have kind of like this here, an increasing to decreasing. So that tells us f will attain the maximum value is going to go back down. So in this case here, all right, this is going to be the local max, and this is going to be local min. So this is max, this is min. Okay, so how do we do that? How do we write that as an answer? We said f of x obtains a local max at this point here, 2 comma f of 2, whatever that is, and then f of x obtains a local min at 4 comma f of 4. So whatever the value that turned out to be honest, we can just crank this into the formula, the function equation to know what that value is. Just right here, that come out to be whatever that is. I don't know. So quickly, actually, you know what? I'm gonna pause the video on this here, and then I'll let you guys kind of watch through this and ask questions in person or on Zoom, so that way you have some time to process that. Okay, let me go ahead and pause.